All right, here's problem 23 off the math subject GRE practice test. We're getting into group theory here, I guess rings. What you are told is that you have Z10 under addition and multiplication. That's your ring of integers mod 10. And S is a subset of Z10 represented by these guys right here. And which of the following statements is false? That's always annoying when they ask for what is false. The first statement says that this subset is closed under addition mod 10. Well, all mod 10 does is it kind of gets rid of all digits except for the ones place. I guess is one way you can think about it because we have this base 10 system. So is this closed under addition mod 10? Sure, it's closed. If you take any two of these numbers and you add them together, what will the ones digit of the resulting number be? Well, an even number plus an even number is an even number, and the ones digit of an even number is always 0, 2, 4, 6, or 8. So this statement is certainly true here. I don't know, even plus even equals even be one argument you could make there. So that's not your answer. It's closed under multiplication. Well, let's see, if I multiply together two even numbers, will I get an even number? Sure. So then this is also a true statement because all even numbers end with one of these 5 digits here. My subset has an identity under addition mod 10. Sure. When you think about an identity under addition, you're probably thinking of 0. That's typically what it is, although you have to be a little bit careful in these different cases here. But 0 does work as an identity element under addition as is defined here, because 0 plus any of these elements is just equal to this element. 0 plus 0 is 0, 0 plus 2 is 0, 0 is 2, 0 plus 4 is 4, 0 plus 6. Okay, you get the point. This is true. Has no identity element under multiplication. Yeah, that seems right, because identity element, you're thinking 1 probably, right? So yeah, that kind of seems like it might be a true statement. Turns out it's not. Turns out that's false. I'll get back to that in just a second. Lastly, the subset is commutative under addition mod 10. Well, sure, it's commutative. You take any of these two numbers, 2 and 6, and add them together, you get the same result as you would get that when you add 6 and 2 together, or 6 and 8 versus 8 and 6. It doesn't matter because addition is commutative. Addition under of this subset, mod 10, is also commutative. So this is a true story. So back to statement D. This subset here, S, has no identity element under multiplication mod 10. So I'm claiming that that is false, that it has no identity. So it's false that it does not have an identity element. Therefore, it's true that it has an identity element. Wait, this has an identity element? When I think of identity element under multiplication, I typically think of the number 1, and there's not a 1 in this subset. So what's going on here? Well, let me show you. Let's see, identity element. It turns out that one of these 5 numbers is in fact an identity element under multiplication for this subset here. Is it 0? Nope. Why not? Well, 0 times 0 is 0, and that's a good thing. It leaves that 0 alone. But 0 times 2, that does not equal 2. So 0 is not an identity element because it doesn't leave 2 alone. It equals 0, not 2. It's a weird way to write that, but fine. What about 2? No, it doesn't work either because 2 times 2 does not equal 2. What about 4? Nope, because 4 times 2 does not equal 4. What about 6? Well, 6 times 2 equals 12, which is 2 mod 10. It looks weird to write that like that. I should put the little equals mod 10 thing down here. Fine, whatever. Okay, but that just shows it works for one element. Does it work for all elements? Well, let's check. 6 times 0, yeah, it leaves 0 alone. 6 times 4, that's 24, so it would leave 4 alone. 6 times 6, yeah, it leaves 6 alone because 6 times 6 is 36. What about 6 times 8? Is there any chance that that's going to end in an 8? Yup. 6 times 8 is 48. That ends in an 8. We already know that these are all commutative. So what that tells me is that when I take 6 and I multiply it by any other element, my answer is that other element. That's exactly your definition of an identity element. So 6, in fact, is an identity element. 8 is not one. Maybe these need x's by them. Because 8 times 2 does not equal 2. But you don't even have to show that 8 is not one because we already found one. We have that 6 is an identity element. So therefore, the statement that there's no identity element is a false statement. So D would be your answer.